Howdy, this is your friendly neighborhood physics teacher here, and we are on the fourth review video for the final. This one is going over waves in general, so it'd be waves in general, sound, and light. This will probably be one of the longest videos just because it's dealing with three different sections, but they all kind of combined. So if you have not watched the earlier three, torque, momentum, or 2D motion, please go back and watch those. In the torque video, I go over a little bit more detail what to expect in the exam itself. But on this one, let's jump into waves. So again, this is the part of your review that's at the beginning. And the first column, you're dealing with variables. The second one, you're dealing with units or constants. The next one, you're dealing with equations. So wavelength. Wavelength is represented with a Greek letter lambda, and it's measured in meters. Your equation for wavelength is wavelength equals velocity over frequency. It's the exact same equation, but you might see it more as velocity equals wavelength times frequency. But it's the same equation that one just solved for wavelength. For frequency, frequency is represented with like a little fancy F. It's measured in hertz, and you can manipulate the equation above again to get frequency equals velocity divided by wavelength, or frequency equals 1 over your period. Period is represented with a capital T. It's measured in seconds, and period would just be 1 over your frequency. There's actually one more representing frequency and period. Period can also equal your time over your number of cycles. And then your frequency will also just get that flip. So number of cycles divided by time. So you have several kind of equations to go along there. Speed of light is represented with c, that's specifically in a vacuum, that is a constant, and so that is 3 times 10 to the 8th meters per second. You can write that as 3 capital E 8, or you can write it as 3 times 10 to the 8th. Either way is correct. Speed of sound in our atmosphere is just represented with V, but that'd be about 340 meters per second. Focal point or focal length is represented just with a small f, no fancy little curves. This one should be fancy. Just a small f. It is measured in meters, and the equation for that is 1 over f, your focal point, equals 1 over di plus 1 over do. Di is your image distance. Do is your object distance. Object distance is represented with a do, measured in meters. Image distance is represented with a di, measured in meters. Object height is represented with ho, measured in meters. Image distance, image height is represented with hi, measured in meters. Magnification is represented with an m. There's no unit for magnification, and you do have an equation that goes with that. You have your m equals, and we use lowercase, not capital. I do apologize about that. So hi over ho equals negative di over do. Of course, you can manipulate any of that to solve for your object height or object image. So you just take out, so it'd be hi over ho equals negative di over do. You just take off the magnification part. Now, a couple of things when you're dealing with your lenses, so let's think about, let me give myself some space here. No, that's not working. Let's try that again. No. Really? Just give me issues. There we go. Give me some space. So when you're dealing with your like mirrors and lenses, a couple of things to know mathematically. If your HI is negative, it means it's inverted. If it's positive, it means it's upright. If your DI is negative, it means it's virtual. I can't spell virtual. Plus, it means it's real. Not red, real. You can do the same thing if your magnification is negative, it means it's inverted. If it's positive, it means it's upright. Another thing, give myself a little bit more space. If your HI is bigger than your HO, then it's magnified. If your HI is smaller than your HO, then it's diminished. Another, looking at if your M is greater than 1, it's magnified. If your M is less than 1, it's diminished. Of course, if your M equals 1, it's the same. You can go back here. If your HI equals your HO, it's the same. So a couple little things to remember dealing with it mathematically. And that is dealing with your optics. So waves in general. What is the difference between transverse and longitudinal waves? Let's make a T-chart for that. So I make these transverse and these longitudinal. So a couple of things. For transverse waves are perpendicular. Perpendicular. So what it means by that, the movement of the wave is perpendicular to how the particles are moving. So the particles move up and down. So the particles move up and down, and the wave itself, the energy of the wave or the wave, moves left and right. So your wave moves left and right. So another thing is your transverse wave tend to be light waves. And your longitudinal waves, they move parallel. And again, the particles vibrate or move left and right, and the wave again is moving left and right, the energy, and they tend to be your sound waves. So those are the big difference between transverse and longitudinal. So 2, which direction do earthquake waves move in? So you think about it, if your earthquake starts right there, which direction does it go in? Well, it goes in all directions. It radiates outward. So it radiates outward in all directions. And actually, the reason earthquakes are so violent is because in one earthquake, there's 2 different types of waves. It's using the longitudinal and the transverse. And it's just going out from its point of origin. So that's why they're so violent, because they're moving perpendicular and parallel to each other, just radiating outward. So 3, what is increasing and decreasing from figures 1 to 2? So if we're looking at figures 1 and 2, let's make it a little bigger so we can see. So we're starting with one big hump versus two humps. So what is that hump representing? Let's think about what that hump is representing. That is representing our wavelength. So that is our wavelength. So our wavelength goes from the full length to half the length. So our wavelength is decreasing. So our wavelength is decreasing. Because let's say if our wavelength was 1, now it's a half. But something that's increasing would be our frequency. Because of our frequency, only 1, that's actually a half, honestly, because it's only a crest. It's not a crest and a trough. So, but we have 1 hump happening versus 2 humps happening. So our frequency is actually increasing. So our wavelength is decreasing and our frequency is increasing. What is the unit for frequency? That is hertz, represented with an Hz. What is the relationship of frequency and velocity? So let's look at our equation. V equals wavelength times our frequency. So we're just looking at frequency and velocity. So if our frequency increases, our wavelength stays the same. Therefore, our velocity has to increase. That is a direct relationship. What is the relationship between wavelength and frequency? So, or wavelength and velocity. So again, if our frequency stays the same, our wavelength increases, our velocity would have to increase. So again, that is a direct relationship. And then what is our relationship between frequency and wavelength? So if our velocity stays the same, let's say our frequency increases, our wavelength would have to decrease. And we saw that in this right here. Our frequency increased, there's more humps, and therefore our wavelength would have to decrease because there's more humps. So that becomes an inverse relationship. So as frequency increases, our wavelength would have to decrease. So which wave that is above, I think yours says to the left because the picture is to the left, but out of these 4 different waves, which one has the longest and shortest wavelength? So again, going back to looking at question 3, so we need to know which one has the longest wavelength and which one has the shortest wavelength. So I would say the longest wavelength. So let's name them 1, 2, 3, 4. So the longest and the shortest. So the longest would have to be, I would say, 3. And the shortest would have to be 2. And again, it's because you're dealing with, there's 1 full wavelength there. You have 1 full wavelength there. 1 full wavelength there. You have 1 full wavelength there. So you could sit there, if you want to scroll in, you can sit there and count the boxes, or you can just kind of eyeball it. You can definitely see that 3 is the longest and 2's the shortest. And then which wave is from above again or to your left is the biggest and smallest frequency. So big frequency, small frequency. Remember, frequency, you can sit there and count. So this one has, you count the crest, basically. So this one has 2 crest. This one has 1, 2, 3 crest. This one has 1 crest. This one has 2 crest. So the biggest frequency would be 2, and the smallest frequency would be 3. Oh, look, it's the opposite. So that goes back to our inverse relationship. Isn't that cool how everything's connected and related? Okay, so number 10. Looking at the graph, what is the amplitude, frequency, and wavelength? So we're just looking at the graph. We're going to scroll in so we can actually see it. So your amplitude is just how high it is. It looks like your amplitude is about 2.5 meters. Your frequency, you just kind of count the crest. 1, 2, 3, 4, 5. So your frequency, well, if you actually want to solve for it, you probably will need to do math. We'll wait on that one. But your wavelength would be 1 crest, 1 trough. So your wavelength would end up being 2 meters, right? Oh, no, because it's time. Nope. So we can do frequency. Because your frequency is just 1 over period. So we can do number of cycles. So there's 1, 2, 3, 4, or in this case, number of cycles over time. And so number of cycles, like I said, you have 1, 2, 3, 4, 5. We'll just do 5 cycles. All right. 5. Yep, 5 cycles in about 10 seconds. So that gets our frequency to be 1/2. And for our wavelength, so our wavelength would end up being, we don't have enough information. We don't have enough information to solve for wavelength. So we're not going to worry about that one. So, there we go. So sound, what part of the wave affects the volume of the sound? That will be your amplitude. Amplitude represents the volume of sound. So the bigger the amplitude, the bigger the sound. The smaller the amplitude, the smaller the sound. What is the order of speed for the different types of mediums that sound can travel through? So the biggest, so if we're going from biggest to smallest, so biggest to smallest, the biggest would end up being solid. Give me that back. Give me that. Would end up being solid. Then it would go to liquid, and then it would go to gas. Sound cannot travel through a vacuum. Sound cannot travel through a vacuum. 13. Yodeler was yodeling and realized that their echo took 5 seconds to get back to them. If the speed of sound is 340, how far away was the mountain that produced the echo? So we have our yodeler, we have our mountain. Now remember the definition of echo. It goes and hits, and then it comes back. So that coming back is the echo. So we do have some givens. It says 5 seconds. Speed of sound is 340, and we're looking for how far away. So our givens, we have t 5 seconds. We have v 340 meters per second. And we're looking, our unknown is distance, but it's distance, our distance up from the mountain. So that's the thing, is the distance from the mountain. So we're just going to use our equations actually going back to like 1D motion, because v just equals distance over time. That's why you have meters per second. Ding, 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 ding. And so our velocity is 340. We're looking for our distance, and we have our time. We need distance by itself. It's being divided. The opposite of divide is multiply. What you do to one side, you got to do to the other. So you just plug in 5 times 340 in your handy dandy calculator. 5 times 340, and you get 1,700 meters. Now, that is the total distance the sound traveled. That is the total distance the sound traveled. The sound traveled from the yodeler to the mountain and then back to the yodeler. That is the echo. But what is the question asking for? The question is asking for how far away is the mountain? How far away is the mountain? So you have to, so that's the distance of the echo. We want to know mountain. So we have to divide that by 2, because the sound travels from you to the mountain and then from the mountain back to you. To get the distance of the mountain, you have to divide your echo distance by 2. So you get 1,700 divided by 2, and you get 850 meters. And that is our answer. So you cannot forget to divide. You cannot forget to divide by 2 on that one. Please don't forget to divide by 2. Okay, so 14. Out of the electromagnetic spectrum, which type is the fastest? So we're dealing with radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So out of all of those, which one's the fastest? Hopefully you're seeing, ha ha ha, tricky, because they're all the same. They're all the same. They all move at the speed of light, which is 3 times 10 to the 8 meters per second. They all move at the same, because they're all light. They are all light waves. So, trick question. Don't miss it. So how is the electromagnetic spectrum organized? It uses 2 things for its organization. It uses wavelength. It uses wavelength. There's an N somewhere. And frequency. So it uses wavelength and frequency. It starts with radio waves, which has a big wavelength. It goes to gamma ray, which has a small wavelength. And so yes. And so then so radio wave goes to gamma wave. So your wavelength goes to big to small. Your frequency goes from small to big. So that's kind of how it's organized. So 16. What is the order of speed for the different types of mediums light can travel through? So again, if we're going from biggest to smallest. The biggest would be a vacuum. It can travel through vacuum fastest, then it goes to gas, then it goes to liquid, and then it goes to solid. So vacuum, gas, liquid, solid. What happens to light when it moves through a lens? So if you have a lens, and you have light rays going through it, when it actually causes a slight bending of the light inside the lens, and that is called refraction. So that is called refraction. So lights refract in lenses. 18. If the object is 4 centimeters from the lens and the image produced is 10 centimeters from the lens, what is the magnitude of the focal length? Now remember, magnitude, the word magnitude just means number. That's what magnitude means. You're not looking for the magnitude. You're looking for the magnitude of the focal length. So magnitude just means number. Don't let that get you confused. So let's write out our givens. So it says that the object, oops, I forgot to highlight object. Said that the object is 4 centimeters. So our distance of the object is 4 centimeters. Our image, so our distance of the image is 10 centimeters. And our unknown, we're looking for focal length, not fancy F. So we're looking for focal length or focal point. And that we can just be measured in centimeters. So we're not going to make you convert on these. So our equation we're going to end up using is 1 over focal length equals 1 over di plus 1 over do. We can just plug in what we got. We're looking for our focal length. Our distance image is 10. Our object distance is 4. You have to do fractions first. So if you want to go ahead and do 1 divided by 10 and get that number, plus 1 divided by 4 and get that number, then you can add. You just can't add. Y'all are still just trying to do the 10 plus the 4. That doesn't work. So get the, and then add them. I'm going to need some more room. And that will give you 0.35. Now, we're not done because that gives us 1 over the focal length. We don't want 1 over focal length. We just want focal length. So what we can do is flip both sides. We can flip both sides. Back that. Need a little bit more room. Okay. And so that gives us our focal length equals 1 over 0.35. And you just plug in 1 divided by 0.35 into your calculator, and you get that your focal length equals 2.86 if you round centimeters. And that is our answer. So there we go. So using the image above, what is the orientation of the image? It would be inverted. Because the image is upside down. Well, just to show you that it's okay to make mistakes, I made a mistake. Normally, I'm not gonna lie, I'd probably stop the video, redo the video so you wouldn't see my mistakes, but just to show you it's okay to make mistakes, I'm gonna say I made a mistake. And it's because the image is inverted, right? And if we go up here, if the image nope, never mind. I didn't make a mistake. Woohoo! Because I was thinking that, the HI is supposed to be negative. So I'm going, oh no, I forgot to put the negative. No, because DI means it's real. And we're good because it's on the real side. I do apologize. This is why you shouldn't make videos, 4 or 5 or 6 videos all at once, because your brain goes squish. That's okay. So if you have any questions, please let Miss Verona or Miss Heath know. This is your 4th video. You have about 3 more left. Happy reviewing. Bye.